Now, in this part 2 of this uh, uh, solar, I call it solar analysis, but we're going to move from solar to battery to hydrogen to ammonia, green hydrogen, blue hydrogen, all of that. But we need to start with getting cheap electricity and see if we can really match these famous really, really low bids that in an earlier video I discussed. Okay, and see if we can get there. And we're going to see if we can get there by working. I went way too far. Come on, come on. Here we go. These bids, this Saudi 1.04, Portugal 1.31, Abu Dhabi 1.35, blah, 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 blah. 1 cent per kilowatt hour. Can we really get there? Okay, and uh, uh, to do that, we're going to work through a whole LCOE analysis, which is I discussed a little in the first one, and I've discussed in different slides. Now, we called a supplier and got kind of some costs for tilted versus single access tracking, and you can see how much the tracking increased the cost. And then in this, and I'm going to show you the final result, and then we're going to work through it. Oh God, if you can watch this whole thing, you'll be amazing. You should get a prize. Maybe I'll give you a special badge or something like that. But the first thing we're going to do is make an adjustment for inflation. And when we make an adjustment for inflation, we have to adjust the O&M in today's currency, and we're going to use a PV function to do that. And then we're going to have to make a similar kind of adjustment where we take the blah, 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 the degradation and increase our cost to recognize that we get less power over time. And we're going to have to use a PV adjustment for that. But we're also going to have to use up here, we're going to have to use a adjustment in the PMT function, if I can find the damn thing, and I'm not sure I can. No, I can't. Oh, shoot. We're going to use the real rate instead of the nominal rate. Sorry to work you through this, and you can get at least, oh, here it is, the nominal and the real costs. And we're going to use a real discount rate and compute the PV of the real discount rate. And then later we're going to make an adjustment for taxes, but not in this video. Okay. And when we do this and make these adjustments, here's going to be what the final result looks like. So if you can have an incredible amount of patience and work through all of this, we're going to put the tilted and the tracking in. We're going to have a separate little section for our capital costs and our capital recovery. And we're going to have to make an adjustment for degradation and reflect that in an interest in the discount rate and compute a carrying charge adjusted for degradation, and we're going to do it on a real basis as well. Here's the one if you wanted to use today's USD, for example, and here's the average kind of blah, blah average blah, over the life. And then when we get to the operating cost, we're going to have to also make these adjustments, and we're going to use a PV formula. And if you just want to look and see how these adjustments are made, you can work through it, and you're going to say, oh, what kind of crapo adjustments are this? And then we're going to work through all the resources and get the LCOE, which is the cost divided by the production. And I guess here, and we'll get a real LCOE, today's USD, a nominal LCOE with inflation. And when we do this, we're going to take all of this data and very quickly in this video throw it in a financial model and prove that when we take these LCOEs, this one we can we can apply a real price or a nominal price, and we're going to prove that this target IRR that we put in is the same thing as the target IRR that comes out. And that's our first step. And once we get this built, we're going to adjust for income taxes, and we're going to finally adjust for some financing uh, costs. But that's not going to be in this video because it turned out this video is too long. So when we make our adjustments for inflation and for degradation, we'll be able to prove that they give you the same thing. And if you can make it through this whole video, oh my gosh, I really can't believe anybody's gonna even watch this thing. But okay, so let's get started. And what I actually did was just kind of made a different video. This was a video I made right at the very a little section I made at the very. Okay, so this is session 2 of the solar project finance analysis. I'm going to try to do a couple of sessions today. I hope I can get a video made without too many interruptions. I can never do this. I've got a mess. So I'm going to the chapter number 4, and then I'm going to the renewable, and we're gonna talk about solar first, and then I'm gonna add a hydrogen to this, and a battery and a wind analysis. Okay, and this is all the stuff I kind of went through before. I formatted the slides a little differently. That's really important. And now where I left off before was I tried to explain. I tried to explain the levelized cost analysis and the fact that you can levelized cost and a financial model are two sides of the same coin, and uh, uh, I think it's very helpful to understand some of the details. And I talked about a little bit now that when we're going to, I'm going to take these costs, by the way. Somebody gave me some, Max gave me some new costs, and we'll make a tilted. We'll make a tilted one, a tilted scenario and a tracking scenario, and we'll put degradation in. We'll put inflation in. We'll do a little bit of analysis on the financing, and let's see if we can do this all in a not too long period of time. Okay, so here's our uh, analysis, and now I'm going to put in this in a sheet. Now I've been teaching, oh God, online. I long so much to see people in person, but people are criticizing me and saying, don't share the screen, don't have other people do the typing and all that stuff and all of this. Now, what I'm practicing a little bit, and when we get to these issues with LCOE, the first thing is we need to get the O&M right, and we need to make an adjustment, and we need to be able to compute all of this data both on a real basis and a nominal basis. And I go crazy with the idea that we should get things computed on a we should get things computed on a real basis. So, for example, if you're comparing a diesel project, and this was a ship, I just had an example of a ship. You want to have either a diesel ship, or maybe a hydrogen ship, or or ammonia ship, or batteries. how are you going to make the batteries work seems to be very tricky for me, because you've got to charge them somehow in the middle of the sea. But maybe we can do that. So we're going to talk about how you make the adjustments. Now, if the diesel price keeps going up and up and up with inflation, and you're comparing that to a nominal price of a battery or something else that's just flat, or solar that's just flat, what a complete, utter, and ridiculous, horrible, disgusting, uneconomic way to do that. It's totally not mismatched. So we're going to do that. We're going to adjust for degradation, and we're going to treat degradation like negative inflation, and we're going to make these kind of different adjustments with the PMT and the PV formula, not NPV, PV, where we put in a kind of a flat rate and just adjust it. And then when we go to the capital cost, we're going to get an adjustment for the degradation, and we're going to compute capital cost on a real and nominal basis as well. And somewhere I have to put the tax adjustments, and it looks like I might have to add a couple of slides for this, and I'm not going to add that. Yeah, I'm going to do this right now, this stupid thing. Just a minute, I'm going to have to pause the video. Look at me. Oh, shoot. Oh, I didn't even record it. Yes, I did. Okay, sorry about the delay and the well, I'll edit the video, whatever. If you have taxes, the first thing you cannot do is take your PMT calculation. Taxes are only in the capital recovery part. O&M, you deduct that from taxes, and you get it back. There's no impact from the O&M. It's only on the capital recovery. You use the to compute the taxes, and we're going to prove all of this in this short, hopefully, session. You can't multiply the PMT times 1 plus the tax rate, because the revenues are increased from the taxes, and then you pay taxes on those revenues, so you divide by 1 minus the tax rate. That's kind of one of the first things I did in the 1970s, late 70s. Then you need to account for the tax depreciation. This increases the LCOE by a lot. Tax rate is 50%, it doubles it. Okay, but then you have to account for the fact that you get to have some tax depreciation, and you treat that like a reduction in capital cost. And when you treat it as a reduction in capital cost, it's at nominal, everything's at nominal rates, not at real rates. Okay, and then you take the NPV of all the tax depreciation rates, and you multiply it by the tax rate. Here's the formula. And you get that's like, so that might be 0.3 or 0.2 or something. And you take the capital cost and you compute, you reflect the tax shield in the capital cost. And finally, sometimes, in a lot of places these days, have a accelerated. It's not a straight line. And that just makes it a little more mechanically complicated. So that's what we're going to do. So let's get started. And I am going to try to do what I've got criticized so badly for just recently. This is when we compute our LCOE, okay, we're going to first start with our capital cost. And let's put a capacity. So I didn't put this, and let's be so careful with the units. And let's make it a solar project. We'll do this with a hydrogen project, a battery project, all the rest of it later, but the principles will be the same. And maybe over here we put tilted. And if you don't like these numbers, I don't care. You know, everybody wants to add in so many development fees, EPC margins, these margins, those margins, marketing fees, extra costs, XYZ, and get the cost high. Well, go ahead, okay? and then we have tracking. And this was kind of interesting. We interviewed somebody. I wasn't on the phone, and they gave us the different costs right away. Okay, and then we have the capital cost. And let's put that in USD per KWP. And I hope in the last video I talked about KWP. KWP is okay. So we're putting the different capital costs in. Let's put the minimum. Let's go for it. And we can show the difference. And then we better put the total capital cost. Now, when I do this, some people complain, oh, why didn't you make a template model? Why I gotta watch you type these stupid things in, or we take too much time typing it in. I'm sorry about that, but okay, so that we start with our total capital costs. No problem. The next thing we do now, this is going to be a little tricky. I guess I have my calculation options not set to a manual, automatic, except data tables. And then let's put the operating cost. And we're going to have to make some adjustments to the operating cost for inflation, because whenever people get this, and then let's put the cost per KWP year. Put a dash. USD per KWP Y, something like that. Okay, so when you're doing your benchmarking, you better make sure. And that's what they did per annum. That's pretty cool the way they did it. And let's get those costs. Now, when you do put these costs in, we have a minimum of 9.08. These have to include everything. If you're doing an LCOE or a financial model, you can't say, oh, I never have to do accounting cost. I never have to have a CEO that looks up to the sky and says it's sunny outside, so let's pay him a million USD or something. I'm just kidding on that one. Okay. Let's put the total cost. Okay, and put USD. Now, this is a little bit maybe simpler than some of the other videos, because I've been working like crazy on the DSRA effects of something. And then let's put our resource. Now I'm going to go through a whole lot of stuff on resources, and I'm sorry I'm skipping back and forth a little bit. I got criticized just for that too. But I'm going to go through really how to measure the resource analysis and how we can get whatever more resources. And I think what I'm going to do for right now is, please, I'm going to go through this very, very quickly in the next session. But I had a case where somebody used helioscope and they got it for free. And they said the in-plane radiation was 2042. And that in-plane radiation, I go crazy with this one single diagram. Come on, get to there. This one, that's determined by somebody upstairs. It's not determined by us. And then we can figure out the capacity factor from nighttime, daytime clouds. But the final capacity to the grid is affected by inverters, wires, cleaning the panels, what kind of panels you put in to avoid the to be affected by the temperature. That's why I go through all these temperature things. So we'll make a couple of scenarios on the performance ratios and other things. But for now, let's use our helioscope. Helioscope gave us 2042. So when we when we start putting this stuff in, if I can find my Excel, excuse me, 2042. So let's put in plane everybody calls this, and we can do it like this. Let's do it like this. kWh per meter squared. Now, if you want to really see how this works, oh shit, 2042. And I hope that I got the right units. I have to check that again. 2042 kWh per meter squared. Now, if you really think about what that means, okay, instead of, I know you would never do it like this, 2042. And this was, I think this was with the tracking, okay? And we might get a little bit less. Let's put 1900 or something without the tracking. I've got real tracking data. Now then you put STC, standard testing conditions, and that's in watt per meter squared. And that's always going to be 1,000. And this one, when we put in plane, this is per year. So we have to be really careful to put it all in the right kind of terms. And then we can put, instead of in plane per year, we can put in plane per hour. And that we can make this watt per meter squared instead of, and we can take this and divide it by 8760 and multiply it by 1,000, because and okay, maybe I'll put 2 decimals on all this stuff, okay, and that's the helioscope. But I'm kind of skipping around a little bit that I get in trouble for, because if we go to PV cyst, we get a little bit different numbers. And I get a yield, and then if we go to the wonderful EU website and we look at how much horizontal and in plane radiation we have that strikes the things, we get different answers. Okay, and I needed to summarize all these. And we'll do that all in our next session. So let's go back. I'm just going to, for now, use this so we can illustrate just a little bit of how this works. And then we can put a capacity factor. And the thing we need to really understand is that this percent is, this capacity factor has no information that is at all different from the yield. And the yield here would be, we could put in kWh divided by kWp, and we would say, okay, well no, let's do this. Let's put the generation before PR, before the performance ratio, kWh. I'm going to review this, but we'll do it. I'm going to multiply this by 8760, and that's our generation. And once we have the generation, then we can also put the in plane yield, which is going to be really stupid. You're going to get kind of pissed at me maybe. And that's just the total amount of generation times divided by the capacity, which happens to be exactly the kWh per meter squared. And that all works because the STC is 1,000. So we didn't have to do all of this. But now let's put the performance rate. Remember, the way to really think about that performance ratio is not to get all fancy and all that stuff about what's in it, the losses, the inverters, the blah, 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 blah. Just think about what's determined by upstairs, clouds and and sunlight, and if you tilt it and do a tracking, you get more. So it's how much sunlight hits the panel, and then the ultimate amount you get is less. And this might be all over the place. And when we look at our case study, we'll see that we get very different kind of results. I'm going to put a high number, and the reason I'm putting a high number is I'll put 2 grid. I just made that thing up. 2 grid capacity factor. Okay, and we just take our in-plane capacity factor. Oh, this stupid thing. How do I do this? Control C, Alt E S W. Okay. Somebody showed me that kind of in a class. So that's our capacity factor. This is not so good. It's okay. Sometimes I see people get a little bit more, and when we do our analysis, we'll get that. But right now, what I'm trying to make absolutely sure is that we understand the mechanics of building up the LCOE. Now, to do that, let's just work through a couple of these adjustment formulas. And the first thing we do is we put let's put let me get one word out. The capital recovery. Okay, and for the capital recovery, I'm gonna, okay, I think I can delete this. We had a degradation up there too. I'm gonna put the capital recovery up here. Okay, and in the capital recovery, I'm going to first put the life. That's one of the biggest things it's driven by, because if you and they said use 30 years, so I'll use 30 years, and then we'll put the target IRR, the target project IRR, and this is, and I'm going to even right now put, because taxes are going to come into this, I'm going to put the call it pre-tax. That's the most basic kind of IRR we can ever get. Okay, and then let's say that's 6%. That's too high, in my opinion. All of you people, and I've been dealing too many with these people who are demanding these absurd returns. They need to get these high returns or they won't do. Okay, and then we can put our basic PMT. And our basic PMT, I'm going to put this as a percentage. I'm going to state that, and we put PMT. But that's just the start. We put PMT and we go to the rate, and then we put the life in, and then I put -1. Now, of course, you don't have to do it like that. You could, instead of that, and then you could put basic capital recovery. Now, and I'm going to put that in USD, and that would be this times the capital cost. Okay, and that's the annual capital recovery, and then we have the O&M cost. This is all not adequate. It's going to take me a little bit longer to make this video, and I don't care right now, but I'm going to make sure that you use it. And then we put LCOE, and then we put capital recovery. Now that's going to be adjusted for taxes, degradation, inflation. That's about all, I guess. USD. We do this in USD because everybody seems to put this in USD. So we take our capital recovery, which is after the PMT, okay? And then we can go over here, Control R, and then we put O and M, and we Control D, and we put our total operating cost. Okay, and then we put our total cost, and we put that in USD, and alternate equal. Okay? And what I'm doing now is really this, we'll make this our LCOE page. And then we'll make another one for our financial model. Okay, and when we make our financial model, we'll go over here, and the first thing we'll do is start with a timeline and put a period. Okay, and we go over here, and I'm going to start with period 0 and Alt EIS, nothing from the generic macros. I'll go up to 50 years in case we have some hydro plant or something like that. And the very first thing I'll put the time flag. And I'm going to try not to hurry too much because we better put our things right, and we'll put the life. Now, when we do this, why don't we also make it a little bit nicer so we can add as many technologies as we want, and let's put our code, our plant code in here, and let's put that as a number 1, and we put equal index and select these, but we can select a whole bunch just in case we want to add wind projects and everything else. And then we can Control D and Control, okay, let's go all the way down. What the heck? Okay, and so we can very quickly get all of this, and let's do just a little bit of Excel, and over here, well, not now. If we put number 2, we'll get tracking, 1 this, and we better eventually put a drop-down box in it here, and we'll put the type of project we're working on. Okay, and for now, I'm going to do this. I'm going to do something stupid, but I insist on this because I cannot stand different models from different places in the world. And there's one place in the world where they always put, what do they call it, control pages, and stick inputs in their control pages. And I'm not telling you where that's from. I hate it. And instead, we'll do this. It's not maybe a great solution, but if you use a reset button, it is a good solution. Okay, so whoops, I need to put that over here. And okay, so now if we can manage our project from a different place, and I don't need these extra things here. So I'm sorry about digressing a little bit into Excel. I get criticized for that a lot too, but we're going to take everything from that column, and I'm going to put, and this thing is greater than 0, and this thing is less than or equal to the number. Okay, and then we'll press Shift Control R, and we'll have our time flag, and then let's we might have a couple of different things when we eventually this is our operating flag. Let's put our construction. I wish I could type a little bit better. I used to be able to type a little bit better. And let's just put, I'm going to cheat with this one. Okay, and then let's now after I do that, I'm going to put our operations. Now, when we have hydrogen and when we have even a diesel project, we're going to start to have a lot of conversions to do. Okay, and for the operations, I'm going to first put the capacity. And let's put that in KWP, and I'm going to put that here. Okay, and then what we'll do, as usual, is we'll put this multiplied by the operating flag. Okay, and we get the capacity, and then we can put capacity factor with a percent, and we'll get that one. And where's our capacity factor? Well, that's down here. Maybe I should have put it kind of upstairs and put it in the same order. That could be argued pretty well. Okay, and oops, I'm going to put Shift Control P, and then we'll put our generation. Okay, and KWH, and that's just going to be the capacity the capacity factor times the capacity, and I always say you need to know 8760. That's what you really need to know. Just about nothing else. And let's make it all wide. And please don't do this one by one ever. And it's still not kind of good. But, you know, and I can't get my Shift Control D to work because of the stupid the video thing. Okay, and then that one guy who tried to work with me yelled at me for grid lines. Oh God! And then let's put the operating cash flow and put the capex in first. Okay, and I guess we could abbreviate it better, but we'll put that from our thing, and then we'll multiply that by the construction period this time. Okay, and then we'll put our OPEX. Now let's put our revenues. Let's put our LCOE as price and put that USD per megawatt hour. Make sure, you know, don't be chintzy with your labels. Okay, and that's the very bottom number, which, oh shit, I didn't compute. Oh my God. Well, that's good. Okay, well, I have to do it now. So we have our total cost here, and then we have our total production. This could be hydrogen, ammonia. I'm going to do an ammonia example. It could be just about anything we do, and we put our capacity factor to the grid, and look at this. I went too fast because I'm slow in my brain, and we put generation. Okay, and we put KWH, and we take our capacity factor, multiply it by our capacity, and multiply it by 8760. Okay, here we have it, and we have a little bit different for our different projects. And then we put our generation down here. That's one of the few factors. And finally, we put our LCOE, and that's in USD per kWh, and that's our total cost divided by this. And then we can also put it in USD per megawatt hours or reals per megawatt hour, whatever you would like. And this is really, this really demonstrates that, okay, in this case, it was better because it was better to do the one that was not a track. And it also demonstrates that we can do this at a fairly low rate. Now, don't think we're finished. Of course, when you get these really, really low project costs, the first thing is we try to get a better capacity factor, and maybe we could get an even lower cost. But the really big thing is what happens if we can get something like 3% cost of capital. Now that's real cost of capital, and then you can start to get to your prices around the USD 2 cents per kilowatt kind of number. So let's get our LCOE, and let's prove that it all works. Okay, and we're just going to put an equal sign, press F4. How about this? Maybe I'll multiply it by the flag. Okay, and then we'll put our revenues. Okay, and once we put our revenues in, and this should not be a shock to you, but what hopefully you would do is don't listen to some of these goddamn people who say, put the development cost in a page, put the CapEx in a page, put the timelines different for everything, put everything together and start with how the project works. I'm sorry, that's style, but for me, and it's important. And then we put OpEx, okay, and then we put that in USD. And then we, for right now, I'm going to put this OpEx as as the total OpEx, 999, and we put that F4 and multiply that by the operating switch, and and I should spell operating right, and then we get our EBITDA. Okay. Now, okay, and this minus this. And then finally, let's put our free cash flow pre-tax. Okay, we're going to have to deal with taxes in the capital recovery, and we're going to have to deal with degradation, and we're going to have to deal with inflation. And the whole reason I did this was to prove that everything works. And the big proof is that we get a project IRR, and we put equal let's put a percent here, and put equal IRR, and get the number, and we get exactly the same result. And we can even put target, and of course, shit. And I know you're saying, oh, why didn't you type the titles in? I'm sorry, because I didn't have time, and whatever. This is our target IRR, and we can put a little test, and it might not work. If we put this equals this, there's a good possibility we'll get a false. But if we round it and subtract it, and then put a comma 0.01, then we should, and then we put equal 0, then hopefully it will work. So that's kind of our test to make sure everything really worked. Okay, now that's that. Whew. I better save this as LCOE, solar course session 2. Okay, what really happened, if you want to know, I'll tell you. Somebody said, come make a course for me, and I said, well, okay, I'll do that. And then I don't know how much they were going to charge and everything else. And they said, oh, you can do it. I said, I don't know. And they were going to have some official cameraman and make it like some sort of movie with a script. And then apparently they couldn't deal with me. So I'm doing it myself anyway for free. Okay, now let's start adding inflation. So up here on the capital recovery, we'll put inflation. And when we do this, it's going to start getting a little more complicated. And we'll put a percent. And let's say we have 2% inflation. Now, what I need to do is, of course, this. So that's the index. Good. And if we have 2% inflation, instead of computing this basic PMT, what we do is we recognize that we're going to have a LCOE that's a lower amount to start with, and that's going to inflate. And a lot of projects have that. And when you inflate, that reduces risk to the equity holder and increases risk to the debt holder. You should understand, because the real IRR is going to stay about the same for the equity holder, but the debt holder, if there's higher inflation, they're going to get a less return, and if there's more or less inflation, the revenues are going to go up or down, and if there's less inflation, the revenues go down, and they get a lower DSCR and all of that. So now we're going to put real payment, and when we do that, the first thing we do is put real return. And make sure when you do this, you don't just subtract. You put 1 plus the nominal return divided by 1 plus the real return. So we're dividing by a number that's bigger than 1, and then we put minus 1. And then you get a number, and it's okay, I should have done it like this. Okay, and then when we do the payment, we put it in real terms, and then you we can I get one stupid word out of my mouth? PMT, and we put in the real rate, and then we put in our period, and I'm going to put a -1 so we can really see what's going on, and then I need to do it here. I should be doing it in one of these other columns, and if I press Shift Control C, I've got column B. I don't really need a header right now, and whatever, we can see. I don't really like that blue stuff anyway, but some people seem to like that kind of crap. Okay, and then we'll but you can really see what the stuff is. Maybe we should put, how about put 3 different things. This is so important. It is important, so you don't waste your stupid time with it. The coloring, you can do whatever you want, and where am I? Okay, then we put the real capital recovery. And that's so far not a big deal. Okay, and that's this number. Well, I'll do it over here. This number times the capital cost. So now instead of it being whatever 4,000 or 3,000, it's lower. And now when we go down to our this, we'll put this. This is the LCOE, and this is the nominal. Now, if we put the real one in, we put our, we can, I guess, copy all this stuff. And the only thing I'm going to change so far is the capital recovery. I'm going to take this number down here instead. Okay, and then I'm going to put in the O&M cost, which we're going to have to make an adjustment to in a minute. And then I'm going to press Alt equal. Whoops, oh no. What did I just do? What happened? I pressed Alt equal. Why didn't it like me that? Maybe I was doing something wrong, okay? And total real. That means it's going to inflate. And then we put the same amount of production we had up here, and we get all of the same results. Okay, I know I have to copy the index thing over and all that, but let's, okay, fine. Let's take this one. Apparently this generation, I didn't do the index on this generation. And, okay. Okay, and then we can put our total cost divided by our total production, and we get a number that's less. And then finally, we take this one and we multiply it by 1,000, and we get a lower number. Now, when you apply this in the model, what I would suggest is then we'll go way up here and we'll put apply real. How's that? If we put that to be true, and then we better do the same thing so these idiots don't use their control page. And I'm sorry I'm saying this so meanly. Okay, and then we right click and we go to format control and we click on this one and we go this page, this page, this page, and we press OK. And then we have either a true or false. So if it's true, we're going to apply the real. So that what that means is I'm going to put over here, and this is not so nice, but what the heck? I'm not going to get totally obsessed with this stuff. If it's the real rate, we're going to take this one down here. Otherwise, we're going to not do this. And then before that, perhaps right up at the top, we should put some macroeconomic stuff. So let's put our inflation index and let's get our inflation rate that we put in. And again, of course, that's constant. And if you do varying inflation, you can't really use all the PMT formulas and everything else. And then we put a 1, and then we inflate it by the end of the first year. Everything kind of occurs at the end when you use any kind of PMT formula. Everything in the assumption is it's all at the end. And then for now, I'm not going to inflate and then you know what I'm going to do is put let's put LCOE as price, and then let's put inflated price. Okay, and let's put it in US. Come on, USD per megawatt hour, and let's put our little flag here, and we'll put equal if it's true. That then we'll put this one times this. Otherwise, we'll just take this one without the inflation. Okay, so now you can see that this. Sorry, why? This one, is that increasing decimal? I hope. Okay, so this is going up with inflation, and then when we should multiply the final price by this one. Now, if we want to get back to where we started, if we don't inflate it, we still get our 6%. Okay, and if we do inflate it, our revenues are going up, and right, and we're getting a higher return. Okay, so where I left is if we put it right now, if we have it nominal, it all still works. But if we have it real, we have too high an IRR. And what I need to do is multiply the operating cost, because they're going to always inflate. So we have this is a real operating cost now, this operating cost. And then it matches, but if I put the nominal in, it doesn't work anymore. And what I need to do is adjust the nominal. We're going to compute both of them. And then I put an inflation factor. Now, there are a couple of reasons to do this. And one is to get the degradation right, and the other one is to just be able to model the inflation right. And you put PV of, and now you use it's going to be a little bit higher than 1. So if you take the PV of the real return and put it over the 30 years, and then put -1, you can put -1, and then take the PV of the nominal return here, and use the same year, and put -1, then you get a factor that's bigger than 1. And we need to, of course, do this. And that now our total cost in real terms is the same. But when we do this in nominal terms, then we take our number, multiply it by our factor, and then put our number. So this is adjusting. And what you've done, I didn't explain it very well because I messed around with it. But basically what you've done is you've, over the life of a project, got a flat, either a flat real rate or a flat nominal rate, and pushed the nominal one up to incorporate inflation. That's the best I can do with that explanation. And then when we go down to our nominal numbers up here, let's take the nominal cost rather than the real cost. And when we go to our financial model, now it works. And it works both in the real one and the nominal one. That's the big deal. Now, while we're at it, let's put degradation in. And I'm going to make model degradation like inflation. I'm not going to divide it by 1 plus, because I got totally worked up about that one. And perhaps down here in our, nope, I'm going to put it up here by our capital recovery. So just underneath inflation, I'm going to put degradation. And let's now, I've heard people going nuts over this, especially the bankers, because they can predict everything else is pretty certain, and they don't know if they can trust this 0.5%. And I've heard some people say that that's just not good enough. We've had lower degradation. I've heard other people say, no, you're totally wrong. The degradation is much higher than that. And why did I just put this in? Now, when we do this, then the first thing we're going to do is we're going to have to adjust the return the same way we did for the you notice I can't type and I can't talk at the same time anymore, but we're going to do the same thing where we adjust the return. This time, instead of inflation, we're going to put a 1 minus, because that we're going to push the return up to give us more money to account for the degradation. And I did this 1 minus the degradation rate. Okay, so this is what kind of return we need up here. And then when we do our real payment, we'll take this adjusted one for the degradation. Okay, and we'll do that again. Now, we're not finished, unfortunately. Okay, and this is kind of painful to go through. But when we have our real return, now we're going to do the same kind of thing and put a degradation adjustment in. And we'll put that as a factor. And we'll put PV of, and this time we're going to use that special degradation rate. And we want the degradation to increase the uh, 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 to increase essentially increase I hope the the expenses. So we'll divide that by the PV at the higher rate, which gives you a lower number, and we'll use our 30-year life. That means we can adjust for the life anytime we want. Okay. Then we we'll put the cost per kWp and put it in after degradation. And let's just make sure this works one by one. And I hope you can see that, okay, when we okay, when we put this stuff in, and it's really worthwhile to test the model. And I meant to copy this one down, and I meant to do this like this. Okay, I copied it down. So this time, when we're going to then go downstairs and treat our we're going to make a degradation index, just like we made the inflation index, and we can bring over our little factor. You can see how nervous I am. Can you tell how nervous I am? Because the timing stuff on these videos is horrible, and I know it's this time I'm going to put a minus here, and I think I did this wrong a little bit because other than that thing, I would like to put our degradation index kind of up here. Let's put our let's call it generation before degradation, and KWH, and I'm sorry you're watching me type this. Remember, if I hope I'm not screwing up. Okay. Okay, and then we'll put our degradation index just, how about we'll put that just below theirs, because what we're really doing is we're reducing this. Now, when you have degradation in just a cost, for example, in an electrolyzer in hydrogen, you just are going to change the cost, not the other one, not the whole capital. It's just going to use more electricity. It's not going to produce less. You'll make a different sort of adjustment. Okay, and then we take this and multiply it by this one. And I just can't use that stupid paintbrush. Sorry about this. And then our total generation is this thing now, so we can still use that. Okay, so we've got the generation going down, and the inflation coming up. And what we absolutely need to do now is to, in our operating costs, we need to use our new operating cost after the degradation. And so this is, let's put total real cost after degradation. And of course we don't need this here, and maybe I'll move this up to here, and this one is going to be this cost multiplied by our capacity here. And if this works, I'll be shocked. And it didn't work. And I'm gonna have to pause the damn video for just a brief moment. And so you don't have to watch me struggling. So I was wrong again. What you need to do is this. It's a little trickier, this one. Now what you're going to do is compute the, in this case I put a gigantic, because I was messing around with it. Let me put our 2% inflation back and our degradation back. When you apply the financial model, when you go into your financial model, you apply with degradation, you notice that this all worked. It's about time we make our color on this. You notice it all worked, and we get a test of true. And what I had to do is put the degradation index, put a lower generation. But when we make our model, we don't adjust for this costs. We adjust the costs for in the LCOE. We adjust the costs. But when we apply these in the model, we still use the same cost because it's going to be driven by, the generation and not the cost. So do you see this 1063? This 1063 goes down here in the O&M recovery to compute the LCOE, but in the financial model, we use the original one. So it's getting a little bit more complicated, and I'm sorry about that, okay? And so let's make sure this works with it doesn't work with the nominal yet. We're going to have to make the same sort of adjustment when we put the inflation. So now we're going to put the inflation factor in, and the inflation plus degradation factor. Okay, and in this case, well, we've got this. We can multiply this by this factor, I think, and we get a bigger factor. And the amount we put in for our total cost nominal with degradation in USD. See, I have to kind of go through this. Is our real cost multiplied by this this factor, and then now when we do our nominal cost, okay, first of all, we're going to include in the nominal cost the O&M, including the degradation down here. Okay, but when we work and go to our financial model, we'll leave this. So let's test it, and it's not going to work, and I'm going to pause the video. It didn't work. See, I knew it. Shit. Okay, so now I fixed it, and this time I'm going to end the video. And instead of going through absolutely everything, I'm going to make sure you see, I went through it and I struggled and all of that. First thing we got to do is we got to get our nominal return adjusted for the degradation in the same way we did the real return. Remember, in the real return, what we did was we divided by 1 minus, whereas this one we divided by 1 plus. Okay, that was our first adjustment. And then we compute the PMT using, I see why, the PMT adjusted for the return and the capital recovery with an adjustment. So suddenly, it's a little bit more complicated. But don't despair. Please don't despair. I struggle with this, I know, but you just got to make a couple of adjustments, and then you've got a present. You can do this in all sorts of different ways. Whatever. And so this number is down in our total nominal here. This is our real, and this is our nominal. Controls this one. Let me go back and use the recovery. Okay, this is our nominal here, alternate U, and we can see where it comes from. And you can see where this one is going, PMT, adjusted capital cost. Or you could go backwards and look at this one and see what the PMT adjustment is. And it's the nominal return. So that's our little alternate U that comes with blah, 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 blah. And with the generic macros. Okay, and then when you go down to the operating cost, it's a pain. But to compute the degradation factor, you take the real return. That's what you start with, and you divide it in the PV adjustment formula. You divide it by the nominal one with after the degradation. This one. Okay, so this we have to get a combined factor of both of them. That's what always kind of drives me a little bit crazy. But now we can do either one. We still get this, and we can see what our LCOE is. Let's put our LCOE right up here. Nominal LCOE is down here, and the good news is I am gonna, for you, I'm not gonna torture you. Nobody's watching this video. Nobody could possibly be still on this one. And the real one is this one. And here we go. Okay, and if we try our other project, the tilted gave us a little bit different one. Now, you might say, I thought you were going to say it's down to 1 US cent per kilowatt hour, and that's because we don't have this a really great capacity factor here. We have a kind of this capacity factor about 18-19%, when some people claim they can get in certainly in the 20s, and some people, I can't believe it, maybe in Saudi Arabia with bifacials we can get even higher. So that's how you can understand, and if there's no land cost, you can cut the cost. So I'm stopping here, and we're going to do the taxes later on, okay? Because this is just too much for certainly for me, and certainly for you.